Hi, all right, let's get started with lecture one. This lecture is kind of an introduction to agriculture and agroecology and the environment. And we're going to start right here at home, excuse me, in Missouri. But before we get started, I want you to look at this picture. And if you had to choose food versus the environment, what would you pick? Yeah, me too. I'm a both and kind of guy. None of this either or stuff. Just kidding. Yeah, we should be able to have both. There's no reason why not. But unfortunately, uh, as it seems in some parts of the world, and even the United States, primarily and a lot of the Midwest, we've done away with a lot of the environment where it was good for growing and we saw use, and we've completely changed and amended it artificially to produce food. And that was a necessary thing. That's a necessary thing as part of a growing civilization society in the past. Uh, but we know more now, and we're moving further now, and cultures are changing around the world, not just here. So we want to look at this aspect of growing food in the environment, how to grow more food, nutritious food, without destroying the environment. That's the struggle. That's the struggle of this class and what we aim to do in agroecology, right, or consumers. So agriculture in the environment, all right, not agriculture and the environment, but agriculture in the environment. So right here, you're looking at two ways in which we do farming, and this is, of course, on the right-hand side, you see what is referred to as a monoculture system, where we have a specialization of one kind of crop being grown. This is what's referred to as industrial agriculture, and it's done all over the world. Agriculture is relentlessly towards specialization. It's just easier to specialize now rather than trying to have the diversity of crops to keep up with livestock, corn, wheat, or pumpkin, or whatever you might be growing. You grow just one thing, you sell it off. Farming once meant growing a diversity of crops and raising livestock, but now much more likely to specialize, growing corn for livestock feed, for example, or raising those hogs. You may only do one of those things. In crop agriculture, specialization means this: monoculture, one type of plant or crop. It allows the efficient use of machinery. It allows machinery and chemicals curtailed and customized just for that crop. It means jobs for salesmen. It means continued inputs and manipulation of the environment in order to get those outcomes. And so this is all part of the monoculture system: more efficient machinery, more efficient sowing of seeds, more efficient harvesting, weed control, and so on and so forth. So it's a natural outgrowth. Monoculture has been a natural outgrowth of an industrial approach to agriculture, which kicked in the late 1800s and early 1900s. And so I'm not saying it's a completely bad thing. It definitely met the need of the growing population. But now that we've had certain success, we can see some of the harms of that success, the byproducts, the law of consequences here. And now it's time to do something about it, as we've seen that it's to some degree destroying natural environments and populations into or by which we depend on growing future food for future generations. So this is where we get down to the science of it, as the science of connections among living things. The ecology in agriculture affords a way of looking at, or I should say ecology, natural systems, gives us a view, gives us a picture, a way of looking at agriculture that immediately expands beyond just tilling the soil here, which is what's happening, or sowing, or cultivating, or harvesting. In agroecology, we move from a narrow concern with farming practices and to the whole universe of interactions among crop plants and soil organisms, insects, insect enemies, environmental conditions, and management actions that that go beyond that, to the effects of farming systems on surrounding natural ecosystems. This class is going to be less about how to change the environment to grow what we want, and more about how do we use the environment to grow what we need, right? And there's wise choices that can be made for that, so we can continue farming into the future and providing. Well, I put this picture in there to show you what agroecology may look like, where you have multiple crops growing in shade. You can have an animal system and crop system, diversifying, using the environment to grow what naturally grows well there. All right, so sustainable ag and the environment. So agroecology's origins are in both the pure science field of ecology and the applied field of agronomy. In one sense, it's designed to teach ecology in the context of agriculture, or in another sense, it teaches about agriculture from an ecological perspective. So this course has real relevance to biologists, to ecologists, to conservationists, as well as to growers, producers, farmers, and the like. So attention will be given to the practice of growing food. However, this is not a class on how to farm. We're not going to learn farm techniques. Farming is an activity that must be adapted to the particular conditions of each region of the world, even within, a state. I'm from Texas, that's a large state, and the practices on the Gulf Coast for growing cotton and the kind of cotton you grow are different from the cotton you grow up in the Panhandle, right, in West Texas. So this is something that we will first talk about as regionalization. Regionalization, the concept that different regions are better adapted to grow certain foods, but not all foods. Could we grow some foods that don't naturally grow there? Yes, and we've obviously shown as humans that this is possible. But is it the best practice? Well, I would posit to you that no, it may not be the best practice. Some cases unavoidable, but not the best practice. So first, let's look at this picture. We're just going to go through several slides that look just like this to see what yields have been like here in the state of Missouri, at least for the crops that we like to grow. So if it is white, there is nothing there. Or it grows, they grow it, but it wasn't enough growth to warrant collecting data. So wherever we see white in these maps, you'll see that it's unpublished, meaning the data is too little to be published, or there was nothing being grown for that crop. But in this case, we're looking at corn yields. This comes from the year 2020. All right, you can see over here just what those amounts. This is yield per acre. Generally, when we say yield per acre, what are we talking about? What are these numbers? Generally, bushels, right? So this can be different. This is a little difficult to explain. So a bushel is a volumetric measurement of about 9.3 gallons. But it's an artifact of culture, of history. We sell all grain by weight, 56 pounds for corn, 60 pounds for wheat and soybean, etc. At some standard moisture that's measured for each of those crops that's specific. And we have to do standard moisture because the moisture is not the same in San Francisco or the coast of California versus the coast of Washington versus Midwest where we are. So whenever we sell grain, it's on a weight basis. But when we talk about it and we store it in bins, we're thinking about volume, because when you put the volume of grain in the wagon or in the bin, you're just going to fill it up. There's a whole 10,000 bushels, and how many pounds it is depends on the grain that you have. Like corn is typically heavier than barley. Wheat is typically heavier than corn. So we have a 56-pound bushel for corn and a 60-pound bushel for wheat, but they'll be the same by volume and for soybean. So in the early days, our fine forefather, President George Bush, helped develop the Department of Agriculture to work out these inequities between colonies and where these things were being grown and taken and traded and sold. The inequities were in weight because of moisture differences, measurements between states and standards that they used. So some states may have a 45-pound bushel, others may have 40 pounds. So we want to get those all equal. You might see a similar kind, something that you see every day, most likely today, is at the gas station. We got to make sure those scales and weights. So you'll see the stamp, Department of Agriculture for State of Missouri. It's been inspected so that those numbers that are turning at the gas pump reflect the actual volume that it says you're getting after you pay that amount, $10 per gallon or whatever it is. Okay. So, anyway, getting back to this, you can see obviously dark green is where there's going to be the most amount of, say, bushels per acre, 180. And the numbers are on each county. I like these maps better. I have some old maps that we'll come across that I did not get to update. So why is this? Why is this all white here? Why doesn't everybody grow their own corn? Yeah, I think the answer already is clear. If you've ever been out west or east, Webster, Wright County, and you get out to Mountain Grove area and you get into West Plains, and yeah, it's all hills and Ozark. It's just it's shallow soil, rocky, not very flat, not very easy to drive a tractor around, and it just doesn't grow well. Obviously, here in the Boot Heel, far east Missouri, we can grow a lot of corn. And then likewise, as we get up here out of the Ozarks, north of the Ozarks, and get closer to Iowa and Illinois and Indiana, we have a lot of corn. So Missouri has its share of corn that we grow. So here is soybean. Just continue to watch the green areas. Again, within the Ozarks and the soil, see that Greene County, let's see, how much corn Greene County? 88.7, not too bad. We're right about, looks like we're in here, yep, below 120. You can look for your county. And this is funny, right? McDonald and Jasper, nothing, but Newton, we have 33, Berry 31, Lawrence 38, and then nothing again. So this is kind of spattered, and the borders could be overlaid, but why is it? Why is it this is green again? We have green going up the east side, and we have some soybeans up in the north. We do have some soybean here, more so across the middle. Think about the environment. If you've ever driven around the state and out of the state in any direction, notice how the landscape changes and how the environment might change just from watching your weather. So regionalization is what this is called, and it means that different crops grow better in different regions, right? There's just some things that won't grow in certain types of soil. You'll learn about those soil types. We'll cover just briefly these later on, but when you take a soils class, you'll learn in more depth. Here is winter wheat. So crazy over here, you have Vernon, Barton, and Jasper County, Dade. These have over 27,000 acres planted. And the yield per acre is over 60. But you look at all these others, it's under 60, average being 65. And you look over here in the Boot Heel, and once again, you want to be thinking about what is so special about the Boot Heel. And right up here, once again, St. Charles can grow a lot of things. But you don't see much winter wheat up here where that corn is grown. So you see spatterings of it. Maybe not a great producer of wheat. We grow our fair share, enough to supply our state and export some for that economy. This, let's see, 2021 was this one. So here, what do I have here? Less than 50 bushels per acre in southwest Missouri. Yeah, I'm looking at my notes. Higher in southeast Missouri. Yeah. So here's sorghum yields. I could not find an updated map. Now we do have data up till 2016 if you go to this website, but they stopped making pictures of the map. We just don't grow a lot of sorghum. Sorghum or millet production depends on an effective and economical insect management. These are heavily infested. We don't eat much sorghum here. Now, Africa or third world countries, they'll eat a lot of sorghum. We have sorghum molasses, and we have things, but we use it mostly as feed here. But if we're going to grow sorghum, you have to plan, and producers are going to have to determine what insects are present and how bad a damage is going to be done to mitigate how much fungicide, insecticide, and whatnot. And it's just an expensive crop to grow here. It doesn't do real well. Tools and technology available for managing grain sorghum insects are going to be mostly cultural practices, the things you do in order that it grows successfully. The selective use of certain insecticides. You're going to have to be scouting that field. You do this with all your crops, but sorghum seems to be delicate here in Missouri, growing even in the Boot Hill, not a whole lot. Looks like once again we have Pike County and St. Charles and Franklin area able to grow sorghum. Rice. Why don't we grow rice? Hey, what's wrong with rice? I love rice. I mean, isn't Springfield known as the Chinese food capital? Where do we get our rice from? Well, not very often here, but we do grow some. Once again, the Boot Hill. That's because rice requires a flood, right? A lot of water. So that's going to be happening in deltas and low-lying areas where water can collect, or right by a large, what is right here? Yep, Mississippi River. Right, we can pull water off there. You get the Missouri River coming through here, and we hadn't talked about that, and we'll get to it. But maybe these are things you're thinking about. The point being the regionalization. Note the similar area for cotton production is also in here in this flat area. So we flood irrigate here, and this is possible. Here in the hills and anything without a flat, I mean, it's going to just, now, in other countries where they do kind of a layering, we'll see that practice later. They get enough rains, and they have a rainy season where they can grow this rice. But the effects of breeding and other agronomic improvements have made up for some of the environmental effects, and we can increase production per acre for rice even here. And I come across the border of Arkansas, and Arkansas grows a lot of rice as well. So does Illinois right out here. If you've crossed the border over there, you might pay double for gas, but you'll get to see some rice paddies. All right. Here's hay, grass hay. Now we're getting somewhere. All right, we finally got some production in the south and the southwest. And we kind of steal it away from Boot Hill. Well, they're too busy growing those other crops. But one thing we can do is grow grass. Now, why would we want to grow grass? Well, before looking at the next slide, let's review the other sides and look at the patterns. Some success in soybean and wheat. Otherwise, not much in corn. There it is, corn, all in the north and in the Boot Hill. All right, and so now we get to looking even at alfalfa hay estimates. Hey, Christian, Douglas, Howell, Oregon, this south central Missouri, successful. Again, St. Charles is up there. Francis, Sullivan, and Livingston. That's interesting. All these places, they're having some success, though not a lot. They're in this upper range of green of alfalfa. And this is because if you've, again, taken the countryside drive, we have a lot of cattle out there. Cattle like good grass, healthy grass. It grows easy in shallow soils. It's a very shallow root system. Monocotyledous or dicotyledous with the clover. And there's plenty of trees, and cows like shade too. So all cattle. This is an old slide. Again, there's updated. Here, let me take it to, let's see. Let me end this slideshow real quick here. And I'm going to take us, oh, come on. Maybe not. Well, my link is not working. Apologies. Look at the cattle data, and I can just tell you. So this was in 2007. We had 71,000 head total. Our total head as of 2021 was 68,000. So that's about 3,000 less head of cattle. A lot less milk cows now, and beef cow number went up to about 37. This went down. I don't remember the number off the top of my head, but so yeah, cattle seem to grow well where grass grows well, and that's what you'll see here. Cattle productions in the Southwest. This is ranch land, cattle country. All right. So the environment has dictated, the topography has dictated, the soil has dictated, the weather has dictated what can grow where. And you look at the Missouri Ozarks, you look at the Missouri Boot Hill, and you see now how those green counties fit right in with these regions in Missouri. And Missouri Ozarks actually comes into Arkansas, as you know, and into northeast Texas. It's rocky, it's stony old mountain soil, and it's not going to be corrupted, disrupted, or destroyed by bringing a tractor plow to it, unless you're in the eastern part of the state, the floodplains, Mississippi over here. Northern Missouri, you have what's considered kind of a glacier soils from a glaciation period. Northwest Missouri, a little different. So 1, 2, 3, 4, 5, 6 different ecozones, 6 different ecozones that we can exploit in a good way to grow crops that would naturally grow there. And I think we're doing that to some degree. So we'll also talk at some length about national distribution. Let's see, where are we at in time? Too long. But we'll talk about national distribution. So not everything we grow in the state of Missouri stays in the state of Missouri. As a matter of fact, we want to make some money from that, right? And so we want to export it to other states that don't have as much. Clearly, I don't know a soul that doesn't eat corn or wheat or have flour or bread. And clearly you see a lot of white on here. This is grain corn, and probably for the cattle as well. Most of this is all feed. All of Iowa is either for biofuel production or feed. I don't think there's a single, well, I say single acre of industrial or commercial farm that doesn't produce corn for either fuel or feed. But anyway, you can see all the counties here. This is 2011 data for production of grain. And I want you to keep looking at it because I'm going to put up a different picture here. Did it come up? There it is. So here we have a shift. If you look carefully at, oh, my pointer's not on. There we go. So I'm going to click back, click forward, and you see Iowa still, but you actually have some white counties in there, and a little less green up here. It's gone down a little more here. Look at California. Let's look at the last slide. We got some light yellow, getting greenish right there in that one county. These guys gave up, and these guys said, we'll do it. These guys have done it. They got good production. Here's Idaho, potatoes. Look, even Idaho now is growing corn for grain 10 years later. Could this be climate change? It could. Are things shifting warmer or cooler, causing more green over here? Worth talking about, worth thinking about. And that's why research in ag and plant science has to always continue. You can't just stop where you've improved and think that's going to last. The environment changes, temperatures change, cycles change, pests change. Every plant, every weed, every insect is trying to spread as far as they can, as fast as they can. That's just the nature of life. It's a cycle of life. You want to reproduce and multiply. It was the order of giving in Genesis. Be fruitful and multiply, and we've tried to. And so this is all going. This is a natural flow. This is natural ecology and how populations change. And we have certain successes. All right. So here's world corn or maize production, like corn in North America and parts of Asia, mostly China, because our temperatures are seasonal length or rainfall patterns or natural resources in soils have those characteristics that make it successful. All right, again, focus on the environment that allows it. Noting here where we got a center of production, a lot of corn here. This is not where corn or maize evolved. It actually came about right here in Mexico and was distributed southward. The potato down here in Peru and distributed this way. And looks like Ireland didn't even rank on the map for growing. Where's Ireland? There we go. Too many potatoes. Got a good blip. Here's the numbers. You like this graph? I do. It's a good visual representation of success. Here, let's look at another potato. Speaking of potatoes, these are sweet potatoes. We talked about so far large crops usually grown as monoculture and why those crops grow in different regions because of the environment, the climate, the soil, and so forth. You could call those agroecozones. Agroecozones, but the same is true for specialty crops like sweet potatoes. So they grow in climates with the right temperature and the soil, etc. We call microclimate. All right, small temperature, moisture-wise, and right here, the heart of sweet potato production in North Carolina. Half of the USA's sweet potatoes are produced in North Carolina. Half of that state's production occurs in just 3 counties. Let's have some of the slides here. Oh, that's a number. Oh, look at that, more sweet potato. Well, no wonder. Oh my gosh, it's getting dinner time. The things you can do with the sweet potato. So if we look at North Carolina up close, you'll see that it's really primarily 3 or 4, just a handful of counties that can grow the sweet potatoes. Why? Well, soil tests might reveal a few things. The climate, distance to processors. It's a heavy crop, sweet potatoes, right? And that's a very heavy crop. They have to ride to the canning factory in a sweet potato bus, you might have heard of. California produces about 3/4 of USA's head of lettuce, about 60%, which comes from Monterey County, California over here. So there are regions where certain foods grow better than others. Strawberries, 88% grown in California. Oh, they're big and juicy. I stopped off by a street stand, got a strawberry. Unlike anything in the store, like a small, about the size of a plum, and I bit into it like an apple. Oh, candy. It was, they got something magic in the soil over there. All right, well, hopefully point made here. The following slides you might see, you're welcome to go through. Developed for the Chinese classes to show that in China, and every state, and there's statistics for this, has something that they can produce. Here's rice production, better than other regions. Wheat production, Xinjiang. You have barley production, all right? And when you look at the topography of China, you'll also see, here's another picture that shows what's grown where, and you can look at the river system. You got the high mountains up here, dust and sandstorms and wind here. The temperature, cold up here, hot and tropical down here. So all these things will influence what can grow where. And you can grow in surplus if you take advantage of it and then export it for money. So that's the way the wheel turns. And this lecture, like I said, is primarily to introduce the idea that certain foods, once again, grow best in certain places. And that's called regionalization. So this is my 30 minutes for this first lecture. Think about, we'll continue, and I'll see you again soon. Remember, if I'm ever getting too slow, just put me on the 1.25, and you'll hear me probably about normal speed.